Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from Group H. So today I want to talk about objective, potential and kinetic energy. So the objective is to study about the principle of potential energy and kinetic energy. So the theory is the mechanical energy is equal to the work done on a body in altering either its position or its velocity. So the next point is three types of mechanical energy. There is potential energy, strain energy, and kinetic energy. The next point is unit of energy is Nm or joule. So the next point is potential energy. It is the energy possessed by a body for doing work by virtue of its position. Potentially energy is P dot E equal M dot G dot H, where M equal mass of the body, G equal gravity of acceleration, H equal distance through which the body falls. Next, kinetic energy. It is the energy possessed by a body for doing work. Kinetic energy K dot E equal 1 over 2 mv square, where m equal mass of the body, v equal its velocity. So next,
The equipment that used in this experiment is first potential and kinetic energy kit, 2 stopwatch, 3 ruler, 4 weight, and the last one is hanger. The procedure of the experiment: first, hang the hanger with weight of potential energy and kinetic energy kit. Second, set the height of the hanger equal to 51 cm from the table surface. Third, release the hanger and at the same time start the stopwatch. Stop the stopwatch when the weight reaches the surface of the table. And the last one, repeat step 4 and repeat step 4.2 and 4.3 with different weight. Next.
Next, exhibition for this laboratory activity. First, mass 0.05 kg, time T1 12.67, T2 11.82, T3 12.17, average 12.22, velocity 119.98 meter per second, positional energy 0.25, kinetic energy 359.28 joule. Second, 0.10 kg, time T1 9.87, T2 6.78, T3 6.58, average 6.74, velocity 66.12 meter per second, positional energy 0.50 joule, kinetic energy 218.860 joule. Third, 0.15 kg, time per second, T1 50.2, T2 5.15, T3 5.30, average 5.15. Velocity is 30.52 meter per second. Positional energy 0.65 joule. Kinetic energy 191.42 joule. Fourth 0.20 kg. Time per second T1 4.06, T2 4.21, T3 4.30, average 4.19. Velocity meter per second 41.10, positional energy 0.0, kinetic energy 168.92 joule. Next 0.25 kg 10 meter per second, T1 3.80, T2 3.71, T3 3.78, average 3.76. Velocity meter per second 60.89, motional energy 1.25 joule, kinetic energy 0 170.11 joule. Next.
Okay, from the results obtained, this is the graph that we have got. This is the potential energy versus kinetic energy graph. This is the y-axis labeled potential energy, and this is the x-axis labeled kinetic energy. From this graph, we can see that as the kinetic energy increases, the potential energy also increases. Therefore, the relationship between potential energy and kinetic energy is that the higher the kinetic energy, the higher the potential energy. From the graph, from calculation, we have obtained that the slope of the graph is equals to 0.21 meters. Now this is the second graph, which is mass times by versus time. From this graph, this we can see that this is the y-axis labeled as mass, and this is the x-axis labeled as time. This is the graph that we have obtained from the result. From this graph, we can see that the higher the time, or the more time taken, the mass increases, or the higher the mass, the more time it takes. From this graph, we can conclude that the relationship between mass and time is that the higher or the more the mass, the more time it takes. From calculation, the slope obtained from this graph is equals to 0.04 meters Okay, I think that's all for now. Thank you.